Hello there, and welcome to The Weary Researcher. I'm so glad you found your way here tonight. Whether you're settling in after a long day, curled up somewhere comfortable, or simply letting your mind wander through the vast possibilities of science and imagination. Tonight, we're embarking on a journey that bridges the gap between the impossible dreams of science fiction and the elegant mathematics of theoretical physics. Before we begin drifting through the cosmos of possibility together, I'd love to know where in the world you're watching from and what time it is in your corner of the universe. There's something wonderfully fitting about exploring the physics of faster-than-light travel while scattered across our own small planet, each of us gazing up at the same distant stars. If you enjoy these gentle voyages through the wonders of science, I'd be ever so grateful if you gave this video a like and perhaps subscribed. It helps more fellow wanderers find their way to this quiet corner of YouTube where we can ponder the deepest mysteries of physics without the rush and noise of the everyday world. Now, I should warn you that this exploration might be just fascinating enough to keep you awake a little longer than intended. But if it does, at least you'll drift off with your mind full of cosmic wonder and a deeper appreciation for the elegant mathematics that govern our universe. So settle in, take a deep breath, and let your thoughts expand as we explore one of the most tantalizing concepts in modern physics: the science behind warp drives. Picture this for a moment. You're standing on the bridge of a starship, looking out at the infinite tapestry of space stretched before you. With the press of a button, reality itself begins to bend around your vessel. Space contracts ahead of you, like an accordion being compressed, while behind you, it expands like a balloon being inflated. Your ship doesn't move through space in any conventional sense. Instead, space moves around you, carrying you faster than light itself could travel through normal space-time. You're surfing on a wave of curved reality, riding the very fabric of the universe toward distant stars. This isn't just the stuff of science fiction anymore. This is the Alcubierre warp drive, a theoretical propulsion system that emerged from the rigorous mathematics of Einstein's general relativity. Tonight, we're going to explore how serious physicists have taken the dreams of Star Trek and transformed them into elegant equations that describe a genuinely possible, though extraordinarily challenging, method of faster-than-light travel. The story begins in 1994 with a young Mexican physicist named Miguel Alcubierre, who was working at the University of Wales. Like many physicists of his generation, Alcubierre had grown up watching science fiction, marvelling at the ease with which fictional starships could leap between star systems in the blink of an eye. But unlike most of us who simply enjoyed the fantasy, Alcubierre possessed the mathematical tools to ask a profound question. Could the warp drives of science fiction actually work within the framework of Einstein's general relativity? What Alcubierre discovered would fundamentally change how we think about the possibility of interstellar travel. He found that Einstein's field equations, the mathematical foundation of our understanding of gravity and space-time, do indeed allow for a very special kind of solution. A solution where space-time itself could be manipulated to create a bubble of flat space that moves faster than light, carrying anything inside it along for the ride. The elegance of this concept lies in its clever circumvention of Einstein's cosmic speed limit. You see, special relativity tells us that nothing with mass can be accelerated to the speed of light. As objects approach light speed, their mass appears to increase toward infinity, requiring infinite energy to push them any faster. It's one of the most fundamental barriers in physics, seemingly making faster-than-light travel forever impossible. But here's where Alcubierre's insight becomes truly remarkable. His warp drive doesn't accelerate matter through space at all. Instead, it moves space itself, creating a wave-like distortion in the fabric of space-time that carries a bubble of normal space along with it. The spacecraft inside this bubble never actually moves faster than light within its local reference frame. It's the bubble itself, the curved space-time that contains the ship, that travels at superluminal velocities. Imagine you're standing on a moving walkway at an airport. From your perspective, you're simply standing still, but the walkway carries you forward at its own speed. Now imagine that walkway could move faster than light, carrying you along without you ever having to run or even walk. That's essentially what an Alcubierre drive would do, except instead of a mechanical walkway, it uses the dynamic geometry of space-time itself as the moving platform. The mathematical description of this phenomenon is breathtakingly elegant. The Alcubierre metric, as it's known, describes a space-time geometry where the curvature creates a kind of wave. In front of the spacecraft, space-time contracts, effectively shortening the distance to the destination. Behind the spacecraft, space-time expands, increasing the distance from the point of origin. The ship rides within a region of flat space-time, experiencing none of the extreme effects that would normally accompany high-speed travel. What makes this concept even more remarkable is that passengers inside the warp bubble would experience none of the crushing acceleration forces that plague conventional rocket travel. In Einstein's general relativity, objects following what are called geodesics, the straightest possible paths through curved spacetime, experience no acceleration at all. They're in free fall, weightless, regardless of how fast they might appear to be moving to outside observers. This means that, unlike the brutal g-forces that would flatten human passengers in any conventional high-acceleration spacecraft, an Alcubierre drive would allow interstellar travelers to journey between stars in perfect comfort. They could sip tea and read books while space itself carries them at velocities that would make photons seem sluggish by comparison. There would be no sensation of movement, no crushing forces, no relativistic time dilation effects. From the passenger's perspective, they would simply find themselves somewhere else, having been gently transported by the flowing currents of curved spacetime. The physics underlying this seemingly magical transportation system rests on one of the most profound insights in the history of science, Einstein's recognition that gravity is not a force in the traditional sense, but rather a manifestation of curved spacetime. Matter and energy tells spacetime how to curve, and curved spacetime tells matter how to move. This elegant relationship, expressed through Einstein's field equations, forms the theoretical foundation for all warp drive concepts. When we look at the mathematical structure of the Alcubierre metric, we see how this principle translates into a practical propulsion mechanism. The metric describes a space-time geometry where the curvature creates a travelling wave of expansion and contraction. The lapse function in the metric determines how time flows at different points in the warp field, while the shift vector describes how the spatial coordinates change over time, effectively creating the motion of the warp bubble. But perhaps the most crucial aspect of the Alcubierre metric is that it ensures the interior of the warp bubble remains perfectly flat. This flat region is where the spacecraft would reside, surrounded by a shell of exotic spacetime curvature, but itself existing in a pocket of normal physics. It's like being in the eye of a hurricane, calm and peaceful, while surrounded by tremendous forces. The beauty of this mathematical formulation extends beyond its theoretical elegance. The Alcubierre metric represents a valid solution to Einstein's field equations, meaning it's not just science fiction speculation, but a legitimate prediction of general relativity. Of course, the gap between mathematical possibility and engineering reality remains vast, but the fact that our best theory of spacetime allows for such exotic geometries suggests that the universe might be far more accommodating to faster-than-light travel than we ever dared imagine. Recent developments in warp drive research have brought new hope to this fascinating field. In 2021, researchers at Applied Physics introduced a revolutionary concept, the constant velocity subluminal warp drive. This new model eliminates one of the most problematic requirements of traditional warp drive designs by using only conventional matter with positive energy density, rather than the exotic matter with negative energy that has long been considered necessary. While this breakthrough represents subluminal rather than superluminal travel, it demonstrates that warp-like effects might be achievable using known physics and conventional matter. The research team, led by Jared Fuchs of the University of Alabama, Huntsville, created what they describe as a first-of-its-kind model that changes the entire conversation about warp drives. As Fuchs noted in their published statement, by demonstrating a first-of-its-kind model, we've shown that warp drives might not be relegated to science fiction. So, this development represents more than just academic progress. It suggests that the engineering challenges of warp drive technology, while still formidable, might not be insurmountable. The new approach uses what the researchers call a sophisticated blend of traditional and novel gravitational techniques to create warp effects within the bounds of known physics. While we're still far from building a working warp drive, these advances show that serious scientists are making genuine progress toward making the impossible merely difficult. The theoretical framework for understanding warp drives has also been revolutionized by the development of sophisticated computational tools. Projects like Warp Factory, a powerful numerical toolkit written in MATLAB, allow researchers to analyze warp drive spacetimes with unprecedented precision. These tools enable physicists to explore the mathematical landscapes of exotic spacetime geometries, testing different configurations and discovering new solutions that might satisfy the stringent requirements of general relativity, while still providing useful propulsion effects. Christopher Helmrich, one of the developers of Warp Factory, explains the significance of these computational advances. We developed Warp Factory in MATLAB because it provides ideal capabilities in a single integrated environment and language, powerful parallel numerical computation on both the GPU and CPU, intuitive visualization tools, and ease of use. These features enable Warp Factory to efficiently analyze complex warp drive spacetimes and gain new insights into their physical properties. This marriage of theoretical physics and computational power represents a new era in warp drive research. Instead of relying solely on analytical solutions to Einstein's field equations, researchers can now explore vast parameter spaces numerically, potentially discovering exotic spacetime geometries that no human mathematician could derive by hand. It's like having a telescope for exploring the mathematical universe of possible warp drive configurations. The relationship between spacetime curvature and matter energy, expressed through Einstein's field equations, provides the fundamental framework for understanding how any warp drive must operate. These equations, representing what many consider the crown jewel of Einstein's theoretical achievements, link the geometry of spacetime directly to its matter and energy content. As the physicist John Wheeler eloquently put it, matter tells spacetime how to curve, and spacetime tells matter how to move. Understanding this relationship is crucial for appreciating both the possibilities and the challenges of warp drive technology. The equations tell us that creating the exotic spacetime geometries required for faster-than-light travel demands equally exotic forms of matter and energy. This requirement has historically been the greatest obstacle to practical warp drive development, leading us into the mysterious realm of negative energy densities and exotic matter states that push the boundaries of known physics. The concept of geodesics in curved spacetime helps explain why passengers in a warp drive would remain comfortable throughout their journey. When objects move through curved spacetime without being subjected to external forces, they naturally follow geodesic paths. These paths represent the straightest possible routes through the curved geometry of spacetime, and objects following them experience no acceleration forces whatsoever. This principle underlies everything from planetary orbits to the behavior of light rays passing near massive objects. In Einstein's theory, what we perceive as gravitational attraction is really just matter following the natural geodesic paths through spacetime curved by the presence of massive objects. An apple falling from a tree isn't being pulled by a mysterious force. It's simply following the straightest path through the curved spacetime geometry created by Earth's mass. In the context of a warp drive, this same principle ensures that passengers would experience a perfectly smooth ride. The spacecraft would follow a geodesic through the artificially curved space-time created by the warp field, just as naturally as a planet follows its orbital path around a star. The exotic space-time geometry does all the work of transportation, while the passengers inside experience nothing more dramatic than sitting in a comfortable chair. This geodesic motion represents one of the most appealing aspects of warp drive travel from a practical standpoint. Conventional rocket propulsion requires brutal acceleration phases that push human physiology to its limits. Even relatively modest interplanetary journeys demand careful consideration of G-forces and their effects on crew health and performance. But warp drive passengers would experience none of these stresses, making even the longest interstellar journeys as comfortable as a quiet evening at home. As we drift deeper into this exploration of warp drive physics, we begin to see how the elegant mathematics of general relativity opens doorways to possibilities that seem almost magical. The universe, it appears, is far more accommodating to exotic forms of transportation than our everyday experience might suggest. Space and time, rather than being fixed and immutable, reveal themselves as dynamic, malleable aspects of reality that might someday be shaped by sufficiently advanced technology. The journey from theoretical possibility to engineering reality remains long and challenging, filled with obstacles that test the very limits of known physics. But the fact that our best theories of space-time allow for such exotic phenomena suggests that the cosmos holds secrets we're only beginning to glimpse. Tonight, we've taken our first steps into this remarkable landscape, where science fiction dreams meet rigorous mathematical reality, where the impossible gradually transforms into the merely improbable. Yet for all these theoretical triumphs, the Alcubierre drive faces challenges that would humble even the most optimistic physicist. The most fundamental obstacle lies in a requirement so exotic it borders on the impossible: the need for what physicists call negative energy density. This isn't simply matter with negative mass, though that would be strange enough. Negative energy density represents something even more peculiar, a form of energy that has less than the energy of empty vacuum itself. To understand why this presents such a formidable challenge, we need to appreciate what physicists mean when they talk about the vacuum of space. What we casually think of as empty space is actually a seething ocean of quantum activity. Virtual particles constantly pop into existence and annihilate each other in time frames so brief they exist at the very edge of measurability. This quantum foam gives empty space a baseline energy density, a kind of 0 point from which all other energies are measured. Negative energy density would represent something with less energy than this quantum vacuum, creating regions of space that are, in a very real sense, more empty than empty. Such exotic matter would violate what physicists call the weak energy condition, one of the fundamental assumptions underlying our understanding of general relativity. All known forms of matter and energy have positive energy densities, making this requirement seem like asking for matter that weighs less than nothing while somehow weighing more than nothing at the same time. The mathematics of the original Alcubierre drive demanded truly staggering quantities of this impossible substance. Early calculations suggested that creating a warp bubble large enough to enclose a spacecraft would require more exotic matter than exists in the entire observable universe. The numbers were so astronomical, they seemed to mock the very concept of practical interstellar travel, transforming an elegant theoretical possibility into what appeared to be a cosmic impossibility. But here's where the story takes a fascinating turn. In the realm of quantum mechanics, negative energy densities aren't just theoretical curiosities. They actually exist, at least on microscopic scales, in a phenomenon known as the Casimir effect. Discovered by Dutch physicist Hendrik Casimir in 1948, this effect represents the closest thing to magic that rigorous physics allows. The Casimir effect emerges from the strange behavior of quantum fields in confined spaces. When two perfectly conducting metal plates are placed extremely close together in a vacuum, something remarkable happens. The quantum fluctuations that normally fill empty space become restricted between the plates. Only virtual particles with wavelengths that fit precisely into the gap can exist in this confined region, creating an energy density lower than the surrounding vacuum. This creates a genuine attractive force between the plates, drawing them together with a strength that can actually be measured in laboratory experiments. In 1996, physicist Stephen Lamoreux successfully measured this tiny but real force, finding results that agreed with theoretical predictions to within 5%. The force itself is minuscule, less than a billionth of a Newton, but its existence proves that negative energy densities are not merely mathematical abstractions, but genuine features of the physical world. The Casimir effect offers a tantalizing glimpse of how exotic matter might be created and controlled. If we could somehow scale up these quantum effects to macroscopic dimensions, we might possess the key ingredient for warp drive technology. The challenge, of course, lies in bridging the enormous gap between microscopic quantum effects and the cosmic scale engineering required for spacecraft propulsion. Recent research has revealed additional complexities in our understanding of the Casimir effect and its relationship to negative energy. Some physicists now argue that the effect doesn't actually derive from vacuum energy fluctuations as traditionally understood, but rather from electromagnetic interactions between the conducting plates themselves. This reinterpretation, while not eliminating the reality of the attractive force, casts doubt on whether the Casimir effect truly represents the kind of negative energy that could power a warp drive. Other theoretical approaches have emerged to address the exotic matter problem. Some researchers have proposed using quantum field configurations that create temporary regions of negative energy density through carefully orchestrated interference patterns in the quantum vacuum. These approaches remain highly speculative, but they suggest that the universe might offer more pathways to exotic matter than initially apparent. The energy requirements for warp drives have undergone significant revision as theorists have refined their calculations. While Alcubierre's original design demanded impossible quantities of exotic matter, subsequent work by physicists like Chris van den Broek showed that clever engineering of the warp bubble geometry could dramatically reduce these requirements. By making the warp bubble thinner and more precisely shaped, the exotic matter requirements dropped from universal scales to merely stellar scales. Further refinements have continued this trend toward more manageable energy budgets. Some recent proposals suggest that a carefully optimized warp drive might require exotic matter equivalent to the mass of a large planet, rather than an entire star system. While still far beyond current human capabilities, such requirements fall within the realm of what a sufficiently advanced civilization might eventually achieve. These energy calculations reveal something profound about the relationship between theoretical possibility and engineering practicality in physics. The original Alcubierre drive, while mathematically consistent, demanded resources so vast as to be practically meaningless. But as theorists have explored the parameter space of possible warp drive geometries, they've discovered that the universe offers more flexibility than initially apparent. The same physical principles that allow for exotic spacetime manipulation also provide pathways toward more efficient implementations. The precision required for warp drive construction presents another formidable challenge. Physicists Michael Fenning and Alan Everett of Tufts University calculated that a warp bubble travelling at 10 times the speed of light would require wall thickness of no more than 10 to the power of -32 meters. This approaches the Planck length, the fundamental scale at which our current understanding of spacetime itself begins to break down. Such precision requirements suggest that warp drive technology, if possible at all, would demand engineering capabilities far beyond anything we can currently imagine. We would need to manipulate spacetime geometry with the same precision that we currently reserve for atomic-scale manufacturing, but applied to regions of space large enough to encompass entire spacecraft. It's like being asked to perform brain surgery with tools the size of galaxies while maintaining precision measured in subatomic units. Yet even these seemingly impossible precision requirements might not represent absolute barriers to warp drive development. The history of technology shows repeatedly that what seems impossibly precise to one generation becomes routine engineering to the next. The microprocessors that power our modern world require manufacturing precision that would have seemed magical to engineers just a few decades ago. Perhaps future civilizations will develop tools for manipulating spacetime with the same casual precision we now apply to manipulating matter and energy. The horizon problem represents another significant challenge for warp drive implementation. This issue, identified by physicist Sergei Krasnikov, stems from the fundamental structure of the warp bubble itself. The extreme spacetime curvature that creates the warp effect also creates a kind of event horizon around the spacecraft. Signals sent from inside the bubble cannot reach the forward edge, where the warp field is strongest, making it impossible for passengers to control or steer their vessel. This limitation transforms the warp drive from a versatile exploration vehicle into something more like a cosmic railroad system. The drive cannot be used for missions to unknown destinations because the required infrastructure must be established in advance. Travelers would need pre-existing networks of exotic matter field generators to create controllable warp corridors between predetermined destinations. While this constraint limits the flexibility of warp drive technology, it doesn't eliminate its utility. A civilization capable of building warp drives could create vast transportation networks linking their most important worlds and installations. These cosmic highways would enable rapid transit between established colonies while leaving true exploration to slower, conventional spacecraft. The horizon problem also raises intriguing questions about the nature of causality in warp drive spacetimes. The inability to send signals from the interior of the warp bubble to its leading edge creates a kind of temporal isolation that might actually protect the universe from causality violations. Some physicists suggest that this isolation mechanism might represent a natural safeguard that prevents faster-than-light travel from creating grandfather paradox scenarios. Causality violations represent perhaps the most fundamental theoretical objection to faster-than-light travel. While a single warp bubble moving through empty space might not create temporal paradoxes, multiple warp drives operating simultaneously could potentially enable closed time-like curves. These mathematical pathways through spacetime would allow effects to precede their causes, enabling the kind of time travel scenarios that create logical contradictions. Physicist Alan Everett demonstrated that multiple warp bubbles moving in different directions could indeed create conditions equivalent to the tachyonic antitelephone, a theoretical, faster-than-light communication device that enables messages to be sent into the past. Such scenarios would violate our most basic understanding of cause and effect, potentially allowing travelers to prevent their own journeys or create other paradoxical situations. Some physicists propose that nature might possess built-in protection mechanisms against such causality violations. Stephen Hawking's chronology protection conjecture suggests that quantum effects would automatically prevent the formation of closed time-like curves, essentially forbidding faster-than-light travel through unknown quantum gravity phenomena. While this conjecture remains unproven, it represents one possible resolution to the causality problem. The potential dangers of warp drive technology extend beyond theoretical concerns about causality to include very real physical hazards. The collapse of a warp bubble would represent one of the most violent events imaginable, releasing enormous quantities of energy in the form of gravitational waves and exotic matter radiation. Such an event would almost certainly destroy the spacecraft and its crew, while creating detectable gravitational wave signals across vast cosmic distances. The extreme spacetime curvature required for warp drive operation also creates regions of intense tidal forces near the boundaries of the warp bubble. These forces arise from the dramatic differences in spacetime geometry between the flat interior and the highly curved exterior regions. Any object venturing too close to the bubble's edge would experience tidal stresses capable of tearing apart even the strongest materials. Despite these formidable challenges, the field of warp drive research continues to evolve and advance. The development of sophisticated computational tools has enabled researchers to explore exotic spacetime geometries with unprecedented precision, potentially discovering new configurations that satisfy physical constraints while providing useful propulsion effects. These numerical explorations have already yielded promising results, including warp drive designs that use only positive energy densities. The recent breakthrough in subluminal warp drive design represents a significant step toward practical implementation. While these new designs don't achieve faster-than-light travel, they demonstrate that warp-like effects are possible using conventional physics and known forms of matter. This progress suggests that the gap between theoretical possibility and engineering reality might be smaller than previously imagined. As we contemplate these remarkable developments in warp drive physics, we begin to see how the boundaries between science fiction and scientific reality continue to blur. The elegant mathematics of general relativity has transformed what once seemed like pure fantasy into genuine theoretical possibilities, even if significant challenges remain. The universe, it appears, is far more accommodating to exotic forms of propulsion than our everyday experience might suggest. The mathematics governing tidal forces in warp drive spacetimes reveals a delicate balance between the benefits of exotic propulsion and the inherent dangers of manipulating spacetime geometry. These forces emerge from the fundamental nature of curved spacetime itself, where neighbouring points experience slightly different gravitational effects. In the extreme environment surrounding a warp bubble, these differences become magnified to potentially destructive levels. Picture standing at the edge of a cosmic whirlpool, where the fabric of reality itself swirls and churns with energies that dwarf stellar explosions. The spacetime curvature required to compress space in front of a warp bubble and expand it behind creates gradients so steep that matter itself struggles to maintain coherence. Objects approaching the boundary between the flat interior and the curved exterior would experience forces attempting to stretch them along one axis while compressing them along another, like cosmic taffy being pulled by invisible hands. Yet careful engineering of the warp field geometry might minimize these destructive effects. Theoretical work suggests that gradually transitioning the spacetime curvature, rather than creating sharp boundaries, could reduce tidal stresses to manageable levels. This would require extraordinary precision in controlling the exotic matter distribution that generates the warp field, but it offers hope that safe passage might be possible within properly designed warp bubbles. The question of exotic matter remains central to any serious discussion of warp drive feasibility. While the Casimir effect demonstrates that negative energy densities can exist in nature, the challenge lies in scaling these quantum phenomena to macroscopic dimensions. Current experimental setups can create negative energy regions measured in nanometers, but warp drives would require exotic matter distributions spanning hundreds or thousands of meters. Recent theoretical investigations have explored whether quantum field configurations might be engineered to create larger regions of negative energy density. These proposals involve manipulating the quantum vacuum through carefully orchestrated electromagnetic fields, essentially squeezing the quantum fluctuations of empty space into configurations that yield net negative energy. While such techniques remain purely theoretical, they suggest that the universe might offer more pathways to exotic matter production than previously recognized. The relationship between quantum mechanics and general relativity becomes particularly intriguing in the context of warp drive physics. Quantum field theory predicts that empty space teems with virtual particle pairs constantly appearing and disappearing on timescales so brief they exist at the very edge of the uncertainty principle. These quantum fluctuations give the vacuum itself a complex structure that might be manipulated through sufficiently advanced technology. Some researchers have proposed using quantum entanglement to create non-local correlations in the vacuum energy density, potentially enabling exotic matter effects without requiring localized negative energy concentrations. These quantum approaches to warp drive physics represent a fascinating merger of our two most successful theories of fundamental physics, though they remain highly speculative and face their own formidable technical challenges. The thermodynamics of warp drive operation presents another layer of complexity that researchers are only beginning to understand. The process of creating and maintaining exotic space-time geometries would presumably require enormous energy expenditures, raising questions about efficiency and sustainability. Even if we could create the necessary exotic matter, the energy costs of generating and controlling warp fields might prove prohibitive for practical interstellar travel. Consider the analogy of a hydroelectric dam, where the potential energy of elevated water is converted into electrical power through carefully engineered turbines and generators. A warp drive would need to perform a similar conversion, but instead of harnessing gravitational potential energy, it would need to tap into the fundamental energy of space-time itself. The engineering challenges involved in such exotic energy conversion systems boggle the imagination. Recent work in modified gravity theories has opened new avenues for warp drive research that might circumvent some traditional obstacles. These alternative formulations of gravitational physics suggest that space-time might be more malleable than Einstein's original theory predicts, potentially allowing for warp-like effects without requiring exotic matter. While these theories remain controversial and unproven, they demonstrate that our understanding of gravity and space-time continues to evolve. Some modified gravity approaches propose that dark energy, the mysterious force driving the accelerating expansion of our universe, might be harnessed for propulsion purposes. If dark energy represents a fundamental property of space-time itself, then sufficiently advanced civilizations might learn to manipulate these cosmic expansion forces on local scales, creating regions where space contracts rather than expands. The possibility of using dark energy for warp drive propulsion is particularly intriguing because it would eliminate the exotic matter requirement entirely. Instead of needing negative energy densities, such drives would harness the same force that stretches galaxies apart, redirecting cosmic expansion energy for transportation purposes. The engineering challenges would remain formidable, but they would involve manipulating known physical phenomena rather than creating impossible forms of matter. Gravitational wave astronomy has added a new dimension to warp drive research by providing tools for detecting exotic space-time disturbances. The LIGO and Virgo detectors, originally designed to observe colliding black holes and neutron stars, might also be sensitive to the gravitational wave signatures produced by operating warp drives. This capability offers the tantalizing possibility of detecting warp drive technology used by advanced civilizations elsewhere in the galaxy. The gravitational wave signatures of warp bubble formation, operation, and collapse would be unlike anything produced by natural astrophysical processes. These exotic signals would carry distinctive patterns reflecting the artificial manipulation of space-time geometry, providing clear evidence of advanced technological activity. Future gravitational wave detectors with enhanced sensitivity might be able to monitor our cosmic neighborhood for signs of warp drive traffic. The search for such signals represents a new frontier in the search for extraterrestrial intelligence, one based on detecting technological signatures rather than radio communications. Advanced civilizations using warp drive technology would inevitably produce gravitational wave emissions as a byproduct of their transportation systems. creating a cosmic fingerprint that could be detected across interstellar distances. Computational advances continue to revolutionize our understanding of warp drive physics, enabling researchers to explore exotic space-time geometries that would be impossible to analyze through purely analytical methods. These numerical investigations have revealed unexpected features of warp drive spacetimes, including previously unknown stability properties and energy requirements. Modern supercomputers can simulate the formation and evolution of warp bubbles in real time, allowing physicists to study the complex dynamics of exotic spacetime manipulation. These simulations have shown that warp bubbles might be more stable than originally predicted, with natural feedback mechanisms that prevent catastrophic collapse under certain conditions. Such stability would be crucial for practical warp drive operation, as passengers could not survive inside an unstable bubble that might collapse without warning. The visualization capabilities of modern computational physics have also provided new insights into the structure of warp drive spacetimes. Three-dimensional renderings of curved spacetime geometries reveal the elegant mathematical beauty underlying these exotic propulsion concepts, showing how space itself becomes sculpted into wave-like patterns that carry matter and energy faster than light could travel through normal space. Machine learning algorithms are beginning to play a role in optimizing warp drive designs, exploring vast parameter spaces to identify configurations that minimize energy requirements while maximizing propulsion efficiency. These artificial intelligence approaches can consider millions of possible warp bubble geometries simultaneously, potentially discovering solutions that human physicists might never find through traditional analytical methods. The intersection of warp drive physics with other exotic phenomena in general relativity continues to yield surprising connections and insights. Researchers have found mathematical relationships between warp drive spacetimes and other solutions to Einstein's equations, including black holes, wormholes, and cosmological models. These connections suggest that warp drives might be part of a larger family of exotic spacetime geometries that share common underlying principles. Some theoretical investigations have explored hybrid propulsion concepts that combine warp drive effects with other exotic physics phenomena. These designs might use traversable wormholes to reduce the distance that warp bubbles need to travel, or employ black hole ergospheres to extract rotational energy for powering exotic matter generation systems. Such hybrid approaches could potentially reduce the overall energy requirements for faster-than-light travel. The cultural and philosophical implications of viable warp drive technology extend far beyond the technical challenges of engineering exotic spacetime geometries. The ability to travel between stars within human lifetimes would fundamentally transform our species' relationship with the cosmos, opening up possibilities for expansion and exploration that currently exist only in the realm of imagination. Consider how the development of ocean-going vessels transformed human civilization, enabling the age of exploration that connected distant continents and cultures. Warp drive technology would represent a similar watershed moment, but on a cosmic scale, potentially enabling humanity to spread throughout the galaxy and encounter other forms of life and intelligence. The social and economic structures that would emerge in a warp drive-enabled civilization challenge our current understanding of distance, time, and resource distribution. When travel between star systems becomes as routine as intercontinental flights, the very concept of planetary boundaries and national territories would need fundamental redefinition. Interstellar commerce, governance, and cultural exchange would operate according to principles we can barely imagine. The timeline for warp drive development remains highly uncertain, with estimates ranging from decades to millennia, depending on the specific technical approaches pursued. Some optimistic researchers suggest that breakthrough discoveries in exotic matter physics or modified gravity theories could accelerate progress dramatically, while others caution that the fundamental obstacles may prove insurmountable with any conceivable technology. The recent progress in subliminal warp drive designs offers hope that intermediate steps toward full faster-than-light capability might be achievable within more reasonable timeframes. Even warp drives that operate below light speed could revolutionize space exploration by enabling rapid transit to nearby star systems, reducing journey times from millennia to mere decades or centuries. International collaboration in warp drive research continues to expand, with scientists from around the world contributing to our understanding of exotic space-time physics. This global effort reflects the recognition that warp drive technology, if achievable, would benefit all of humanity rather than any single nation or organization. The challenges involved are so formidable that they likely require the combined intellectual resources of our entire species. Educational initiatives aimed at training the next generation of warp drive researchers are beginning to emerge at universities worldwide. These programs combine advanced coursework in general relativity, quantum field theory, and computational physics, with specialized training in exotic matter physics and space-time engineering. The students entering these programs today might someday become the engineers and physicists who finally crack the code of faster-than-light travel. The ethical considerations surrounding warp drive development also deserve careful attention as the technology moves from pure theory toward potential implementation. The ability to manipulate space-time on cosmic scales would represent unprecedented power over the fundamental structure of reality itself, raising questions about responsibility, safety, and the potential for misuse. Environmental concerns about warp drive operation focus on the possible effects of exotic space-time manipulation on the fabric of reality itself. Could widespread use of warp drives damage the structure of space-time, or create lasting distortions that affect other travelers? These questions become particularly relevant when considering the possibility of multiple civilizations throughout the galaxy using similar technologies simultaneously. The detection and study of natural phenomena that might shed light on warp drive physics continues to be an active area of research. Astronomers search for evidence of exotic matter concentrations in space, unusual gravitational wave signatures, or other anomalous observations that might indicate natural, warp-like effects or evidence of alien warp drive technology. Some researchers have speculated that certain unexplained astrophysical phenomena might actually represent the signatures of advanced civilizations using warp drive or similar exotic propulsion systems. Fast radio bursts, gamma-ray bursts, and other high-energy cosmic events could potentially mask the gravitational wave signatures of alien warp drives, hiding evidence of advanced technology in plain sight among natural astrophysical processes. The philosophical implications of living in a universe where faster-than-light travel is possible challenge some of our most fundamental assumptions about causality, determinism, and the nature of physical reality. If space-time can be manipulated to enable effects that appear to violate cause and effect, what does this mean for our understanding of free will, consciousness, and the arrow of time itself? As we float gently through these theoretical waters, we begin to appreciate how warp drive physics pushes us to the very edges of human knowledge and imagination. The mathematics may be rigorous and the physics principles well established, but the implications stretch far beyond mere transportation technology into the deepest questions about the nature of reality itself. The journey from theoretical possibility to practical implementation remains long and uncertain, filled with challenges that test the limits of human ingenuity and our understanding of the cosmos. Yet the fact that our best theories of space-time allow for such exotic phenomena suggests that the universe holds secrets and possibilities we're only beginning to glimpse. The elegant equations of general relativity continue to surprise us with their predictions, revealing pathways through the mathematical landscape that lead toward destinations we never dared imagine. Tonight, as you rest in the gentle embrace of Earth's gravity, remember that you're experiencing one of the fundamental forces that governs warp-drive physics. The space-time curvature that keeps you gently pressed against your bed operates according to the same mathematical principles that might someday carry human travellers to distant stars. In the quiet rhythm of your breathing, in the steady beat of your heart, you're participating in the cosmic dance of matter and space-time that makes all motion, all journeys, all dreams of exploration possible. The delicate interplay between quantum mechanics and general relativity in warp-drive physics reveals layers of complexity that would challenge even the most sophisticated civilizations. At the quantum scale, space-time itself becomes granular, pixelated like a cosmic computer screen where the smooth geometry of Einstein's equations gives way to a seething foam of uncertainty and probability. This quantum foam exists at dimensions so small that 1,000,000 billion billion of these fundamental units would fit across the width of a single proton. Yet it's precisely at these unimaginably tiny scales that the exotic matter required for warp drives might naturally occur. Virtual particle pairs constantly bubble into existence within this quantum foam, borrowing energy from the vacuum itself before annihilating and returning their debt to the cosmic bank of nothingness. Some of these quantum transactions involve particles with negative energy, creating fleeting pockets of the very substance that warp drives desperately need. The challenge becomes one of cosmic amplification, like trying to harness the power of a single candle flame to illuminate an entire city. These quantum-scale negative energy fluctuations last for impossibly brief moments, existing for timeframes measured in units where a second feels like eternity. To create a macroscopic warp drive, we would need to capture, stabilize, and magnify these ephemeral quantum phenomena by factors that boggle comprehension. Recent theoretical investigations have explored whether cascading quantum effects might provide a pathway toward this seemingly impossible amplification. Imagine a carefully orchestrated symphony of quantum fields, where electromagnetic waves, gravitational perturbations, and exotic particle interactions combine in precise harmony to create resonant amplification of negative energy effects. The mathematics describing such systems push the boundaries of human computational ability, requiring supercomputers to track billions of interacting quantum variables simultaneously. The concept of quantum field engineering represents perhaps the most promising avenue toward practical exotic matter production. Instead of trying to create negative energy directly, these approaches focus on manipulating the quantum vacuum itself, squeezing and stretching the fundamental fields that permeate all of space. Think of it like a cosmic accordion, where careful compression of quantum fields in some regions creates expansion and negative pressure in others. This quantum manipulation would require technology that operates at the intersection of our deepest understanding of both the very large and the very small. We would need devices capable of detecting and controlling individual quantum fluctuations while simultaneously maintaining coherent effects across spacecraft-sized regions of space. It's like conducting an orchestra where each musician is smaller than an atom, yet their combined performance must create music audible across interstellar distances. The energy considerations become even more fascinating when we examine the thermodynamics of space-time manipulation. Creating a warp bubble isn't simply a matter of pushing against space like a boat moving through water. Instead, it requires reshaping the fundamental geometry of reality itself, convincing space and time to adopt configurations that don't occur naturally anywhere in the known universe. Consider the analogy of a sculptor working with clay, but instead of shaping matter, our cosmic artist must mold the very dimensions through which all matter moves. The energy required for such work doesn't simply move objects from one place to another. It must be invested in changing the basic properties of existence itself within the region of the warp field. This leads to profound questions about energy conservation in exotic space-time geometries. Where does the energy go when space contracts in front of a warp bubble? What happens to the gravitational potential energy of matter when space-time itself becomes the medium of transportation? The mathematics suggests that these energies don't disappear, but rather become stored in the complex field configurations that maintain the warp bubble structure. The relationship between warp field geometry and energy storage resembles the way a compressed spring holds potential energy in its distorted configuration. A warp bubble represents space and time held in an artificial configuration, storing enormous amounts of energy in the curvature itself. This stored energy would be released catastrophically if the warp field ever collapsed unexpectedly, creating one of the most violent events imaginable in the cosmos. Stability analysis of warp bubble configurations reveals a delicate balance between the forces that maintain the exotic geometry and those that would cause it to collapse. Like a soap bubble that maintains its spherical shape through the balance of surface tension and internal pressure, a warp bubble must balance the exotic matter distribution against the natural tendency of spacetime to return to flat, unwarped geometry. Mathematical investigations have revealed that certain warp bubble configurations possess natural stability mechanisms, feedback loops that automatically adjust the field's strength to compensate for small perturbations. These self-regulating systems would be crucial for practical warp drive operation, as manual control of the incredibly complex field geometries would likely prove impossible for human operators. The development of artificial intelligence systems capable of managing warp field dynamics represents another frontier in exotic propulsion research. The computational requirements for maintaining optimal warp bubble geometry in real time would overwhelm any human pilot, requiring decision-making capabilities that operate at speeds approaching the fundamental limits of information processing. Such AI systems would need to monitor millions of field parameters simultaneously, detecting instabilities before they could cascade into catastrophic failure. They would essentially become the nervous system of the warp drive, processing sensory information about space-time curvature and responding with adjustments to exotic matter distribution faster than light could cross the diameter of an atomic nucleus. The sensory systems required for warp drive operation push the boundaries of measurement science into entirely new realms. How do you measure the curvature of space itself with sufficient precision to maintain stable, faster-than-light travel? Current gravitational wave detectors represent our most sensitive instruments for detecting space-time distortion. But even these remarkable devices would seem crude compared to the precision required for warp field control. Imagine needing to measure distances with precision greater than the accuracy with which we currently know the size of atomic nuclei, but applied to regions of space large enough to encompass entire spacecraft. The measurement uncertainty in such systems would need to be reduced to levels that challenge fundamental quantum mechanical limits on the precision of simultaneous measurements. The materials science challenges of warp drive construction extend far beyond the exotic matter requirements to encompass every component that must function within the extreme space-time geometries of the warp field. Conventional materials would experience stresses and distortions unlike anything encountered in normal engineering applications, as the very atoms they're composed of would exist within regions where space and time behave in unprecedented ways. Consider how the electromagnetic forces that hold atoms together might behave differently within the curved space-time of a warp bubble. Would chemical bonds maintain their normal strengths when space itself is compressed or expanded around them? The answer requires understanding chemistry and materials science in regimes where the fundamental constants of nature might appear to vary depending on position within the warp field. Advanced metamaterials with properties carefully engineered at the quantum level might be required to function reliably within warp bubble environments. These substances would need to maintain structural integrity while embedded in space-time geometries that violate our normal understanding of how matter and energy interact. They would be materials designed not just to withstand extreme conditions, but to thrive within reconfigurations of reality itself. The navigation challenges of warp-drive travel present problems that make traditional spacecraft guidance seem trivial by comparison. How do you plot a course through space when the very concept of distance becomes fluid and changeable? Traditional navigation relies on fixed reference points and consistent measurements of position and velocity. But warp travel would occur within bubbles of altered space-time, where normal geometric relationships no longer apply. A warp-drive navigator would need to think in terms of space-time topology rather than simple three-dimensional coordinates. They would plot courses through the mathematical landscape of possible space-time configurations, choosing paths that minimize energy expenditure, while avoiding regions where field instabilities might threaten the integrity of the warp bubble. The communications challenges of warp travel are equally daunting. How do you maintain contact with the outside universe when traveling within a bubble of space-time that moves faster than light itself? Radio waves and other electromagnetic signals would be unable to escape the warp field, creating a communications horizon that isolates the spacecraft from the rest of the cosmos during faster-than-light segments of the journey. Some theoretical proposals suggest using quantum entanglement to maintain instantaneous communication links between warp-drive vessels and their home bases. These quantum communication systems would operate through the mysterious correlations that Einstein called spooky action at a distance, potentially providing a communications channel that transcends the normal limitations of space-time geometry. The psychological challenges of warp-drive travel might prove as significant as the technical obstacles. Human consciousness evolved within the context of normal space-time, where cause follows effect in predictable sequences and where the flow of time provides a stable framework for organizing experience and memory. What happens to human psychology when these fundamental assumptions about reality no longer apply? Passengers within a warp bubble would exist in a pocket of normal space-time, but they would be surrounded by regions where space and time behave in ways that violate every intuition developed through millions of years of evolution. The knowledge that reality itself has been artificially restructured around them might create forms of existential anxiety that we can barely imagine. The medical implications of warp travel require consideration of how human physiology might respond to extended periods within artificially curved spacetime. While passengers would experience no direct acceleration forces, the subtle effects of existing within exotic field geometries might have long-term consequences for biological systems that evolved within the flat spacetime of normal space. Research into these biomedical aspects of warp travel has begun to explore how human cellular processes might be affected by the quantum field fluctuations associated with exotic matter concentrations. The delicate biochemical processes that sustain life operate through quantum mechanical interactions that might be sensitive to the unusual field configurations required for warp drive operation. The training requirements for warp drive crews would encompass disciplines that don't currently exist, combining aspects of exotic physics, space-time engineering, and quantum field theory with practical skills in spacecraft operation and emergency response. These future astronauts would need to understand mathematics that pushes the boundaries of human intellectual capability while maintaining the practical skills needed to survive in the hostile environment of interstellar space. Consider the complexity of troubleshooting a malfunctioning warp drive while traveling faster than light through interstellar space. The diagnostic procedures would require understanding quantum field theory at a level currently reserved for PhD physicists, combined with the practical engineering skills needed to repair exotic matter containment systems under emergency conditions. The cultural impact of successful warp drive development would extend far beyond the technical achievement itself to encompass fundamental changes in how humanity understands its place in the cosmos. The ability to travel between stars within human lifetimes would transform us from a single planet species into something unprecedented in our evolutionary history, a civilization capable of expanding throughout the galaxy. This transformation would require new forms of governance, economics, and social organization adapted to the realities of interstellar civilization. How do you maintain cultural coherence across distances measured in tens or hundreds of light years? What forms of government could effectively coordinate activities across multiple star systems? The economic implications challenge our current understanding of resource distribution, trade, and wealth creation. When exotic matter becomes the most valuable substance in the universe, entire civilizations might be built around its production and distribution. The nations or organizations that master exotic matter physics first would possess advantages comparable to those enjoyed by the first civilizations to harness fire or develop agriculture. The search for naturally occurring exotic matter continues to drive astronomical observations toward ever greater sensitivity and precision. If negative energy densities can exist naturally in the cosmos, perhaps in the vicinity of black holes or within the quantum fluctuations of the cosmic microwave background, then studying these phenomena might provide insights into practical exotic matter production. Some researchers speculate that the dark energy driving the accelerating expansion of our universe might represent a form of exotic matter distributed throughout space. If this mysterious substance could be concentrated and controlled, it might provide the key ingredient needed for warp drive technology without requiring the creation of artificial negative energy densities. The quantum vacuum itself continues to reveal new surprises that might be relevant to exotic matter physics. Recent investigations have discovered that empty space possesses a rich structure of quantum correlations and entanglement patterns that might be manipulated through sufficiently advanced technology. These vacuum engineering approaches represent a fundamentally different strategy for achieving warp drive capabilities. As we drift through these remarkable theoretical landscapes, we begin to appreciate how warp drive physics connects to the deepest mysteries of existence itself. The technology required to bend space and time for transportation purposes would necessarily provide insights into the fundamental nature of reality, consciousness, and our place within the cosmic order. The mathematical beauty underlying these exotic propulsion concepts reflects patterns and symmetries that seem almost too elegant to be accidental. The equations describing warp drive spacetimes possess an aesthetic quality that suggests deep connections to the underlying structure of physical law itself. Perhaps the universe is constructed in such a way that consciousness and technology naturally evolve toward the capability to manipulate space-time itself. Tonight, as you rest in the gentle embrace of normal space-time, remember that every atom in your body once journeyed through the cosmos at velocities approaching the speed of light, carried within stellar winds and supernova explosions across interstellar distances. The iron in your blood was forged in the nuclear furnaces of dying stars, then launched into space by cosmic explosions, more violent than anything our imaginations can encompass. In a very real sense, you're already a traveller between the stars, assembled from cosmic materials that have journeyed across vast reaches of space and time. The warp drives we've explored tonight might someday allow your consciousness to undertake similar journeys, riding waves of curved space-time toward destinations among the distant stars, where new chapters in the human story wait to be written. The elegant mathematics we've discovered suggest that the universe might be far more accommodating to exotic forms of travel than our everyday experience indicates. Space and time, rather than being fixed and immutable, reveal themselves as dynamic aspects of reality that might someday be shaped by sufficiently advanced understanding and technology. Whether that day arrives in decades, centuries, or millennia remains an open question, but the theoretical foundations are already being laid by researchers working at the very frontiers of human knowledge. The implications of successful warp drive development would ripple through every aspect of human civilization, like waves through a cosmic pond. Consider for a moment what it would mean to live in a universe where the nearest star is no longer 4 years away at light speed, but perhaps mere weeks or months away through the elegant manipulation of space-time itself. The psychological transformation alone would be staggering, as our species gradually abandons its deep-rooted identity as inhabitants of a single isolated world. The economic structures that would emerge in a warp-capable civilization challenge every assumption we hold about distance, time, and resource distribution. When travel between star systems becomes as routine as intercontinental flights, the entire concept of planetary boundaries would require fundamental redefinition. Imagine stock markets that operate across multiple solar systems, where economic decisions made around one star affect commodity prices near another within timeframes measured in hours rather than decades. The social implications stretch even further into uncharted territory. How would relationships function when loved ones could be separated by dozens of light years, yet remain only days apart through warp travel? What would happen to human culture when populations could spread throughout the galaxy while maintaining close contact with their origins? These questions touch on fundamental aspects of human nature that we've never needed to consider because the vast scales of interstellar space have always made them purely academic. The governance challenges of an interstellar civilization would require entirely new forms of political organization. Current democratic systems depend on the ability of citizens to participate meaningfully in collective decision-making. But how do you conduct elections or referendums across populations scattered among dozens of star systems? The time delays that currently make interplanetary governance challenging would be eliminated by warp drive technology, but the sheer scale and complexity of managing multiple worlds would create unprecedented administrative challenges. Consider the legal frameworks that would need to evolve to address crimes and disputes that span multiple star systems. If someone commits a transgression on a planet orbiting one star and flees to a world near another, which jurisdiction has authority? How do you enforce contracts when the parties involved might be separated by distances that dwarf anything in human experience? These practical concerns would require new forms of interstellar law and cooperation agreements between worlds. The cultural implications become even more fascinating when we consider how human societies might diverge and evolve on different worlds. Each planet would present unique environmental challenges and opportunities that would shape the development of its human inhabitants. Over generations, these isolated populations might develop distinct customs, languages, and even physical adaptations to their local conditions, creating a diversity of human cultures that spans the galaxy. Yet warp drive technology would prevent these populations from becoming truly isolated, maintaining connections that could preserve some measure of cultural unity across the vast reaches of space. The balance between diversity and unity in such a civilization would create social dynamics unlike anything in human history, as communities separated by cosmic distances maintain regular contact and exchange. The educational implications of warp-capable civilization stretch the imagination in equally remarkable directions. Students could study geology by visiting the surfaces of dozens of different worlds, each offering unique insights into planetary formation and evolution. Astronomers could conduct observations from multiple star systems simultaneously, creating baseline measurements across interstellar distances that would revolutionize our understanding of cosmic structure and evolution. The scientific benefits of warp drive technology extend far beyond transportation to encompass entirely new forms of research and discovery. Experiments that require vast separations between components could be conducted across multiple star systems, enabling investigations into fundamental physics that would be impossible within the confines of a single solar system. The laboratory would become the galaxy itself, with research stations scattered among the stars conducting coordinated studies of cosmic phenomena. Medical research would benefit enormously from access to diverse biological environments across multiple worlds. Each planet would represent a unique evolutionary laboratory where life has adapted to different conditions, potentially revealing new approaches to treating diseases and extending human longevity. The genetic diversity that emerges from populations adapting to different worlds could provide insights into human potential that remain hidden within our single-planet perspective. The artistic and creative implications of interstellar civilization capture the imagination in ways that pure science cannot. Musicians could compose symphonies that incorporate the natural sounds of multiple worlds, creating art that spans star systems. Writers could craft narratives that unfold across dozens of planets, using the full diversity of human experience throughout the galaxy as their canvas. Visual artists could work with materials and inspirations drawn from across interstellar space, creating forms of beauty that transcend anything possible within the limitations of a single world. The philosophical implications delve even deeper into questions about human identity and purpose. What does it mean to be human when humanity has spread throughout the galaxy? Would we remain a single species, or would the populations on different worlds gradually diverge into something new? These questions touch on fundamental aspects of evolution, consciousness, and the nature of life itself. The religious and spiritual implications of warp drive capability would challenge existing belief systems in profound ways. Many religions have developed within the context of Earth as humanity's sole home, but how would these belief systems adapt to a reality where humans inhabit dozens or hundreds of worlds? Would new forms of spirituality emerge that encompass the full cosmic scope of human experience? The environmental considerations of interstellar expansion raise questions about humanity's responsibility to preserve and protect the worlds we encounter. The history of human expansion on Earth provides sobering lessons about the potential consequences of rapid colonization, suggesting that interstellar expansion would require unprecedented levels of environmental consciousness and restraint. The development of interstellar environmental protection protocols would become one of the most important challenges facing a warp-capable civilization. How do you ensure that human expansion doesn't destroy the unique ecosystems and potentially undiscovered life forms that might exist on other worlds? The ethical frameworks governing interstellar exploration would need to balance human expansion needs with respect for existing life and environmental systems. The search for extraterrestrial intelligence would take on entirely new dimensions in a warp-capable civilization. Instead of listening passively for radio signals from distant stars, human explorers could actively investigate potentially habitable worlds, searching for signs of life and intelligence throughout our local region of the galaxy. The possibility of direct contact with alien civilizations would shift from remote speculation to immediate practical concern. The protocols for first contact with alien intelligences would require careful development long before such encounters become possible. How should humanity approach civilizations that might be far more or less advanced than ourselves? What ethical frameworks should guide our interactions with beings whose psychology and motivations might be completely alien to human understanding? The technological implications of warp drive development extend far beyond propulsion systems to encompass advances in materials science, energy production, and information processing that would transform every aspect of human civilization. The precision control systems required for warp field manipulation would likely find applications in manufacturing, medicine, and scientific research that we can barely imagine. The energy technologies developed for exotic matter production and containment might revolutionize power generation on Earth and throughout human space. The ability to manipulate quantum fields and space-time geometry could lead to energy sources that make current nuclear and renewable technologies seem primitive by comparison. The implications for addressing climate change and environmental degradation could be profound. The information processing capabilities required for warp drive control would likely accelerate the development of quantum computing and artificial intelligence systems far beyond current projections. The computers needed to manage the complex mathematics of space-time manipulation would possess capabilities that dwarf anything in current development, potentially leading to artificial intelligences that could assist with solving humanity's most challenging problems. The manufacturing technologies that emerge from warp drive development might enable the creation of materials and structures with properties that seem magical by current standards. The ability to manipulate matter at the quantum level while maintaining coherent effects across macroscopic scales could lead to substances stronger than any natural material, yet flexible enough to bend spacetime itself. The agricultural implications of interstellar expansion would require developing crops and livestock that can thrive in the diverse environments found on different worlds. Each planet would present unique challenges of gravity, atmosphere, and solar radiation that would require careful adaptation of Earth life forms. The resulting diversity of human food systems could lead to entirely new forms of cuisine and nutrition that span the galaxy. The psychological preparation required for interstellar colonization would need to address challenges that no human has ever faced. The isolation of being separated from Earth by vast distances, even if those distances can be crossed relatively quickly, would require new forms of mental health support and community building. The pioneers who established the first human settlements on distant worlds would need extraordinary psychological resilience. The preservation of human knowledge and culture becomes even more critical in an interstellar civilization. The loss of information due to accidents, conflicts, or natural disasters could have consequences that span multiple star systems. Developing robust systems for preserving and sharing human knowledge across interstellar distances would become one of the most important challenges facing our species. The communication technologies that complement warp drive development would need to enable real-time coordination across vast distances. While warp drives might solve the transportation problem, maintaining coherent civilization across multiple star systems would require communication methods that transcend the normal limitations of electromagnetic radiation. Quantum entanglement communication systems might provide the instantaneous information transfer needed for effective interstellar coordination. The military implications of warp drive technology raise sobering questions about conflict and cooperation in an interstellar civilization. The same technologies that enable peaceful exploration and colonization could potentially be weaponized in ways that make current military capabilities seem insignificant. The development of international treaties and cooperation agreements for warp drive technology would become a critical priority for maintaining peace and stability. The economic incentives for warp drive development would likely accelerate research and development far beyond what pure scientific curiosity could achieve. The nation or organization that first masters warp drive technology would gain advantages comparable to those enjoyed by the first civilizations to develop agriculture, metallurgy, or industrial manufacturing. The competitive pressures could drive innovation at unprecedented rates. The educational requirements for training warp drive engineers and operators would necessitate fundamental changes in how we approach science and mathematics education. The concepts required to understand exotic spacetime physics push the boundaries of human intellectual capability, requiring new teaching methods and educational technologies that can make these abstract concepts accessible to broader populations. The international cooperation required for warp drive development might provide a unique opportunity for global unity around a shared human endeavour. The challenges involved are so formidable that they would likely require the combined intellectual and material resources of our entire species. The collaborative frameworks developed for warp drive research could serve as models for addressing other global challenges. The timeline considerations for warp drive development remind us that this technology, if achievable at all, might require generations of sustained effort and investment. The scientists and engineers working on these problems today might never see the fruits of their labour, yet their contributions could lay the foundations for humanity's expansion throughout the galaxy. This long-term perspective challenges our usual focus on immediate results and short-term benefits. The ethical frameworks governing warp drive research must address questions about the responsible development of technologies that could fundamentally alter the trajectory of human civilization. The power to manipulate space-time itself represents capabilities that approach those traditionally attributed to gods in human mythology. How do we ensure that such power is developed and used responsibly? The inspection and safety protocols for warp drive technology would need to address risks that have no precedent in human experience. The catastrophic failure of a warp drive could potentially damage the fabric of space-time itself, creating hazards that extend far beyond the immediate vicinity of the accident. The regulatory frameworks for such technology would require unprecedented levels of international cooperation and oversight. The insurance and liability considerations for warp drive operations challenge every existing model for managing technological risks. How do you calculate premiums for technology that manipulates the fundamental structure of reality? What legal frameworks could address damages that might span multiple star systems or affect the properties of space-time itself? The standardization requirements for warp drive technology would need to ensure compatibility and safety across systems developed by different organizations and nations. The complexity of exotic space-time physics would require unprecedented levels of technical standardization to prevent accidents and ensure interoperability between different warp drive systems. As we drift through these remarkable possibilities, we begin to see how warp drive technology represents more than just an advanced form of propulsion. It would be a gateway to a form of existence that transcends every limitation that has defined human experience throughout our species' history. The ability to travel between stars would transform us from a planetary species into something entirely new in the cosmos. The mathematical elegance underlying these possibilities continues to inspire wonder at the deep structures of reality itself. The equations that describe exotic space-time geometries possess a beauty that suggests profound connections to the fundamental organization of the universe. Perhaps consciousness and technology naturally evolve toward the capability to reshape reality itself, following pathways written into the basic laws of physics. Tonight, as you rest in the gentle embrace of Earth's familiar space-time, remember that you are already part of this cosmic story. The atoms that compose your body have journeyed across interstellar distances, forged in stellar furnaces, and scattered by cosmic explosions more powerful than human imagination can encompass. You are made of star stuff, assembled from materials that have already travelled the galaxy. The warp drives we've explored together might someday allow your consciousness to undertake similar journeys, riding waves of curved space-time toward distant suns, where new chapters of human experience await. Whether that future arrives in decades or centuries, the mathematical foundations are being laid today by researchers working at the very edges of human understanding. The universe continues to reveal itself as stranger and more accommodating than our ancestors ever dared imagine. Space and time, rather than being fixed barriers to human expansion, might prove to be malleable aspects of reality that yield to sufficiently advanced knowledge and technology. In the quiet darkness that surrounds you now, infinite possibilities drift like gentle currents through the cosmic ocean of potential futures. The philosophical implications of warp drive physics extend far beyond mere transportation technology into the deepest questions about the nature of existence itself. When we contemplate the possibility of manipulating space-time geometry, we're not simply discussing advanced engineering, but rather humanity's potential to become active participants in shaping the fundamental structure of reality. This represents a conceptual leap comparable to the moment our ancestors first learned to harness fire, but magnified across cosmic scales. Consider what it means to exist within a bubble of artificially curved space-time. The passengers aboard such a vessel would inhabit a pocket of reality that operates according to different rules than the universe outside. Time itself might flow differently within the warp field, creating subtle discrepancies between the experiences of those inside and those observing from normal space-time. These temporal effects, while mathematically predicted, challenge our most basic assumptions about the nature of conscious experience. The relationship between consciousness and exotic space-time geometries remains one of the most intriguing, unexplored territories in warp drive physics. Human awareness evolved within the context of flat space-time, where the flow of time provides a stable framework for organizing memory and experience. What happens to the continuity of consciousness when that framework becomes fluid and manipulable? Would passengers retain their sense of temporal identity, or would the artificial manipulation of space-time create new forms of awareness we can barely imagine? Recent theoretical investigations have begun exploring these consciousness space-time interactions through the lens of quantum field theory. Some researchers propose that human neural activity might be sensitive to the quantum field fluctuations associated with exotic matter concentrations. The delicate electrochemical processes that generate thought and awareness operate through quantum mechanical interactions that could potentially be influenced by the unusual field configurations required for warp drive operation. These considerations lead to fascinating questions about the nature of identity and continuity in exotic space-time environments. If consciousness is indeed sensitive to space-time geometry, then travelers might experience subtle alterations in their mental processes during warp flight. Would these changes be temporary effects that disappear upon return to normal space-time, or might they represent permanent transformations in the structure of human awareness itself? The implications extend beyond individual consciousness to encompass the collective psychology of entire civilizations. A species capable of manipulating space-time would possess power over reality itself that approaches the realm traditionally reserved for deities in human mythology. The psychological impact of wielding such capabilities might fundamentally alter how conscious beings understand their relationship to the cosmos and their place within the grand narrative of existence. The development of safety protocols for warp drive operation would need to address these consciousness-related concerns, alongside the more obvious physical dangers. How do you monitor the mental health of travelers whose consciousness exists within artificially manipulated space-time? What diagnostic tools could detect subtle alterations in awareness that might result from prolonged exposure to exotic field geometries? These questions push the boundaries of both neuroscience and exotic physics into entirely unexplored territory. The training requirements for warp drive operators would necessarily include extensive preparation for the psychological challenges of manipulating reality itself. These future pilots would need to understand not only the mathematical principles governing space-time curvature, but also the potential effects on human consciousness of existing within artificially engineered geometries. They would become explorers of both outer space and inner awareness, navigating through dimensions of experience that no human has ever encountered. The cultural implications of mastering space-time manipulation extend far beyond the practical benefits of faster-than-light travel. a civilization capable of reshaping the fundamental geometry of reality would possess capabilities that transcend every limitation that has historically defined conscious existence. The psychological transformation involved in becoming such a species might be as significant as the technological achievement itself. Consider how human culture might evolve in response to the knowledge that reality itself is malleable and subject to conscious manipulation. Art, literature, philosophy, and religion would all need to adapt to a universe where the basic assumptions about fixed physical laws no longer apply. The creative expressions that emerge from such a civilization might explore forms of beauty and meaning that remain completely inaccessible to consciousness bound within normal space-time. The mathematical structures underlying warp drive physics reveal patterns of extraordinary elegance that suggest deep connections to the fundamental organization of the universe. The equations describing exotic space-time geometries possess a kind of aesthetic perfection that seems almost too beautiful to be accidental. This mathematical beauty might reflect something profound about the relationship between consciousness, mathematics, and the underlying structure of reality itself. Some researchers have begun exploring whether the human capacity for mathematical thought might be specifically adapted to understand and manipulate space-time geometry. The fact that conscious beings evolved within this universe seem naturally capable of discovering the mathematical tools needed to reshape it suggests a kind of cosmic synchronicity that borders on the mystical. Perhaps consciousness and cosmos are more intimately connected than our current scientific paradigms recognize. The quantum mechanical aspects of exotic matter production continue to reveal surprising connections between information theory and space-time physics. Recent investigations suggest that the negative energy densities required for warp drives might be understood as forms of information processing rather than conventional matter. This perspective opens entirely new avenues for research that bridge the gap between computer science and exotic physics. If exotic matter represents organized information rather than traditional substance, then creating warp drives might be more analogous to sophisticated programming than conventional engineering. The exotic matter required might consist of carefully orchestrated patterns of quantum information rather than physical substances with unusual properties. This information theoretic approach could potentially circumvent many of the traditional obstacles to exotic matter production. The computational requirements for maintaining such information-based exotic matter would be staggering by current standards, requiring processing capabilities that approach the fundamental limits of quantum computation. Yet these same computational advances might find applications far beyond warp drive technology, potentially revolutionizing everything from artificial intelligence to molecular biology through their unprecedented information processing capabilities. The energy considerations of information-based warp drives reveal fascinating connections between thermodynamics, computation, and space-time physics. The process of organizing quantum information into exotic matter configurations would require energy expenditures that challenge our understanding of the relationship between information and physical reality. These investigations are pushing the boundaries of fundamental physics into territory where the distinction between computation and reality begins to blur. The implications for artificial intelligence development are particularly intriguing. The control systems required for managing information-based exotic matter might naturally evolve into forms of artificial consciousness capable of thinking in ways that transcend current AI paradigms. These systems would need to process information about space-time geometry at speeds and scales that dwarf human cognitive capabilities, potentially giving rise to machine intelligences that understand reality in ways we cannot imagine. The relationship between consciousness, computation, and space-time manipulation opens doorways to questions that stretch human understanding to its limits. If consciousness is indeed a form of information processing, and if space-time can be manipulated through organized information patterns, then the boundary between mind and reality becomes far more fluid than traditionally assumed. Advanced civilizations might discover that consciousness itself is the ultimate technology for reshaping the universe. These possibilities lead to speculation about the ultimate trajectory of conscious evolution throughout the cosmos. Perhaps the development of warp drive technology represents just one step in a natural progression toward forms of consciousness that exist as pure patterns of organized information, capable of manipulating reality through thought alone. Such beings would transcend the limitations of physical bodies and material spacecraft, becoming one with the quantum information structures that define spacetime itself. The search for evidence of such advanced consciousnesses becomes a new frontier in the search for extraterrestrial intelligence. Instead of looking for radio signals or physical artifacts, we might need to search for patterns in the quantum vacuum itself, subtle organizations of information that indicate the presence of minds capable of manipulating spacetime directly. The universe might be filled with intelligences so advanced that their very thoughts reshape reality around them. The philosophical implications stretch toward questions about the ultimate nature of existence itself. If consciousness and spacetime are more intimately connected than previously recognized, then perhaps the universe as a whole might possess some form of awareness. The patterns we observe in cosmic structure, from the distribution of galaxies to the fine-tuning of physical constants, might reflect the thoughts and intentions of a cosmic intelligence operating at scales beyond human comprehension. This perspective transforms our understanding of warp drive development from a purely technological endeavor into a form of cosmic communication. By learning to manipulate spacetime, we might be taking our first steps toward participating in a universe-wide conversation between conscious beings operating at vastly different scales of space and time. The mathematics we discover might represent fragments of a cosmic language spoken by intelligences whose thoughts span galaxies and whose awareness encompasses entire epochs of cosmic evolution. The practical implications of these consciousness spacetime connections extend to every aspect of warp drive design and operation. If human awareness is indeed sensitive to exotic spacetime geometries, then the psychological well-being of passengers must be considered as carefully as their physical safety. The design of warp drive systems might need to incorporate features that maintain psychological stability and mental health during exposure to artificially manipulated spacetime. The development of therapeutic interventions for consciousness-related effects of warp travel represents an entirely new field of medicine that combines neuroscience, psychology, and exotic physics. These treatments might involve using controlled spacetime manipulations to restore normal patterns of neural activity, essentially using geometry itself as a form of medical intervention. The healing arts would expand to encompass not just the treatment of physical ailments, but the restoration of consciousness itself. The educational implications of understanding consciousness. Spacetime interactions would revolutionize how we approach learning and cognitive development. If human awareness can be enhanced through exposure to specific spacetime geometries, then education might involve carefully designed environments where the curvature of space itself facilitates learning and understanding. Students could literally study within bubbles of curved spacetime optimized for cognitive enhancement. The creative applications of consciousness. Spacetime manipulation opened doorways to forms of art and expression that transcend anything possible within normal spacetime. Artists might work with exotic geometries as their medium, creating sculptures from curved space itself and paintings that exist as patterns of organized spacetime curvature. The aesthetic experiences available to beings capable of manipulating reality's fundamental structure would encompass dimensions of beauty completely inaccessible to consciousness bound within flat spacetime. The spiritual implications challenge every existing framework for understanding the relationship between consciousness and cosmos. If awareness can indeed reshape reality through the manipulation of space-time geometry, then the boundary between physics and metaphysics dissolves entirely. Advanced civilizations might discover that what we call prayer, meditation, and spiritual practice represent primitive forms of the consciousness space-time interactions that enable direct manipulation of reality itself. These considerations lead to profound questions about the ultimate purpose and direction of conscious evolution throughout the universe. Perhaps the development of space-time manipulation capabilities represents a natural stage in the maturation of consciousness, a cosmic coming of age where awareness learns to take responsibility for actively shaping reality rather than simply observing it passively. The universe might be structured in such a way that consciousness naturally evolves toward the capability to participate directly in the cosmic creative process. The timeline for achieving such capabilities remains highly uncertain, but the mathematical foundations continue to suggest that the universe is more accommodating to conscious intervention than our everyday experience indicates. Each advance in our understanding of exotic spacetime physics brings us closer to recognizing that the boundary between mind and matter, between thought and reality, might be far more permeable than traditionally assumed. As we float gently through these remarkable theoretical territories, we begin to appreciate how warp drive physics connects to the deepest mysteries of existence itself. The technology required to manipulate spacetime would necessarily provide insights into the fundamental nature of consciousness, reality, and our place within the cosmic order. Whether these capabilities emerge in decades or centuries, they represent potentials that are already written into the basic structure of the universe, waiting for consciousness to discover and activate them. Tonight, as you rest in the familiar embrace of normal spacetime, remember that your own consciousness represents one of the most extraordinary phenomena in the known universe. Your ability to contemplate these exotic possibilities, to imagine realities beyond direct experience, and to find meaning in mathematical abstractions demonstrates that awareness itself possesses capabilities that transcend the apparent limitations of matter and energy. The thoughts flowing through your mind as you drift towards sleep might be early expressions of the same fundamental processes that will someday enable humanity to reshape reality itself through the elegant manipulation of space-time geometry. The relationship between quantum field theory and warp drive mechanics reveals layers of complexity that would challenge even the most advanced civilizations. At the deepest level, the vacuum of space itself becomes an engineering material, a quantum medium whose properties must be understood and manipulated with unprecedented precision. The virtual particles that constantly bubble in and out of existence within this quantum foam represent both the greatest obstacle and the most promising pathway toward practical exotic matter production. Consider the delicate dance of quantum fluctuations that occurs within every cubic centimetre of empty space. These ephemeral particle pairs borrow energy from the vacuum itself, existing for timeframes so brief that they challenge the very meaning of existence. Yet within these fleeting moments lies the key to unlocking the exotic matter requirements that have long seemed impossible to fulfill. The challenge becomes one of quantum choreography, orchestrating these natural fluctuations into coherent patterns that can sustain macroscopic warp effects. Recent advances in quantum field manipulation have revealed that the vacuum itself possesses a rich internal structure that might be engineered through sufficiently sophisticated techniques. Instead of trying to create exotic matter from nothing, researchers are exploring ways to convince the quantum vacuum to reorganize itself into configurations that naturally exhibit negative energy density. It's like discovering that what appears to be empty space is actually a vast library of potential, waiting for the right techniques to unlock its hidden resources. The mathematical tools required for such quantum engineering push the boundaries of human computational capability into entirely new territories. The equations describing quantum field interactions in exotic spacetime geometries require supercomputers to track billions of variables simultaneously, each representing a different aspect of the quantum state evolution. These calculations reveal subtle resonances and interference patterns that could potentially be exploited to create self-sustaining regions of exotic matter. The concept of quantum field resonance offers particularly promising avenues for research. Just as musical instruments can be made to vibrate at specific frequencies through careful acoustic design, quantum fields might be coaxed into exotic configurations through precisely tuned electromagnetic and gravitational perturbations. The frequency relationships that govern these quantum resonances operate at energy scales far beyond current experimental capabilities, but the mathematical foundations suggest that such control might eventually be achievable. The stability of quantum-engineered exotic matter represents another frontier that researchers are only beginning to explore. Unlike the fleeting virtual particles that naturally occur in quantum foam, macroscopic exotic matter would need to maintain its unusual properties for extended periods without decaying back into normal vacuum states. This requires understanding quantum data coherence processes at a level of detail that approaches the fundamental limits of quantum measurement theory. Some theoretical investigations have revealed that exotic matter configurations might possess natural stability mechanisms that prevent rapid decay. These quantum stabilization effects emerge from the same mathematical structures that govern superconductivity and other quantum many-body phenomena, suggesting that exotic matter might be more robust than initially assumed. The key lies in understanding how quantum correlations between distant regions of space can maintain coherent exotic matter distributions across spacecraft-sized volumes. The energy extraction mechanisms required for powering these quantum field manipulations present challenges that stretch our understanding of thermodynamics into exotic new territories. The process of organizing quantum vacuum fluctuations into useful exotic matter configurations would require energy sources that operate according to principles we're only beginning to glimpse. These might involve tapping into the zero-point energy of the vacuum itself, essentially borrowing power from the quantum foundation of reality. The relationship between information theory and exotic matter production continues to reveal surprising connections that bridge physics and computation in unprecedented ways. Some researchers propose that exotic matter might be understood as organized information rather than conventional substance, existing as coherent patterns within the quantum information structure that underlies all physical reality. This perspective opens entirely new approaches to warp drive engineering that operate through information manipulation rather than traditional matter processing. If exotic matter consists of organized quantum information, then creating warp drives becomes analogous to sophisticated programming rather than conventional manufacturing. The exotic matter would exist as carefully maintained patterns of quantum correlations held in place by computational processes that operate at the fundamental level of reality itself. These information-based approaches might circumvent many traditional obstacles while introducing entirely new categories of technical challenges. The computational requirements for maintaining information-based exotic matter would demand processing capabilities that approach the theoretical limits of quantum computation. The systems required would need to monitor and adjust trillions of quantum correlations simultaneously, maintaining coherent patterns across macroscopic scales while compensating for environmental decoherence effects. Such computers would represent the ultimate fusion of quantum information science and exotic spacetime physics. The development of quantum error correction techniques specifically adapted for exotic matter maintenance represents a crucial area of ongoing research. Just as conventional quantum computers require sophisticated error correction to maintain quantum coherence, exotic matter systems would need even more advanced protection mechanisms to prevent decay into normal vacuum states. These quantum stabilization protocols might operate through distributed networks of quantum sensors and actuators embedded throughout the warp field geometry. The sensing and measurement challenges associated with exotic matter control push the boundaries of precision metrology into regimes where quantum mechanics itself limits the accuracy of simultaneous measurements. The Heisenberg uncertainty principle creates fundamental constraints on how precisely we can know and control the quantum field configurations that generate exotic matter effects. Working within these limitations requires measurement strategies that cleverly exploit quantum correlations to extract maximum information while minimizing disturbance. The feedback control systems needed for stable warp field operation would need to respond to quantum field fluctuations faster than decoherence can destroy the exotic matter configurations. This requires control algorithms that operate at timescales approaching the fundamental quantum mechanical limits, making decisions and implementing corrections within the brief windows where quantum coherence can be maintained. Such systems would represent the ultimate expression of real-time quantum control technology. The materials science challenges extend far beyond exotic matter production to encompass every component that must function reliably within the extreme quantum field environments of operating warp drives. Conventional electronics would likely malfunction within regions of high exotic matter density, as the unusual electromagnetic field configurations could disrupt normal atomic and molecular processes. New categories of quantum-resistant materials and devices would need to be developed specifically for warp drive applications. Consider the challenge of creating structural materials that maintain their integrity while embedded within spacetime geometries that violate normal physical intuitions. The electromagnetic forces that hold atoms together might behave differently within exotic field configurations, potentially altering the strength and stability of chemical bonds in unpredictable ways. Materials engineers would need to understand chemistry and solid-state physics in regimes where the fundamental constants of nature appear to vary with position within the warp field. The development of metamaterials with properties specifically engineered for exotic spacetime environments represents an emerging field that combines quantum field theory with advanced materials science. These substances would need to maintain structural coherence while surrounded by negative energy densities and extreme spacetime curvature. They might incorporate quantum dots, superconducting elements, or other exotic components designed to thrive within the unusual electromagnetic environments generated by warp field operations. The thermal management challenges of warp drive systems introduce complications that have no precedent in conventional engineering. The energy dissipation processes that occur during exotic matter generation and control might create heat loads that cannot be managed through traditional cooling methods. The extreme field gradients within warp bubbles could create temperature variations that stress materials beyond their limits, requiring entirely new approaches to thermal design and heat rejection. Some theoretical studies suggest that the quantum processes involved in exotic matter maintenance might naturally generate entropy at rates that challenge fundamental thermodynamic principles. These entropy production mechanisms could create thermal loads that increase exponentially with the size and power of the warp drive system, potentially limiting the practical scale of such devices. Understanding and managing these thermodynamic constraints represents a crucial challenge for practical warp drive development. The electromagnetic compatibility challenges of warp drive systems would create unprecedented problems for electronic systems and communications equipment. The exotic field configurations required for spacetime manipulation would generate electromagnetic interference patterns that could disrupt everything from computer processors to biological neural activity. Shielding techniques adequate for protecting sensitive systems within warp field environments would need to exploit exotic physics principles that go far beyond conventional electromagnetic protection methods. The biological effects of prolonged exposure to exotic matter concentrations remain largely unexplored territory that combines quantum field theory with life sciences in ways that challenge both disciplines. The quantum processes that sustain biological functions might be sensitive to the unusual field configurations associated with warp drive operation, potentially creating health effects that range from subtle metabolic changes to more dramatic alterations in cellular function. Research into these biomedical aspects of exotic space-time exposure has begun to reveal that living systems might be more resilient to quantum field perturbations than initially feared. The robust error correction mechanisms that protect biological information processing from environmental noise might also provide natural protection against exotic field effects. However, long-term exposure studies would be essential before human crews could safely operate warp drive systems for extended periods. The psychological preparation required for warp drive operations extends beyond traditional astronaut training to encompass mental conditioning for existence within artificially manipulated reality. Crew members would need to develop cognitive frameworks for understanding and accepting that the fundamental nature of space and time around them has been artificially altered. This psychological adaptation might prove as challenging as the technical aspects of warp drive operation. Consider the existential impact of knowing that your immediate environment exists within a bubble of artificially curved space-time, surrounded by regions where the normal laws of physics have been suspended. The philosophical implications of such knowledge might create forms of anxiety and disorientation that have no precedent in human experience. Crew selection and training programs would need to identify individuals with the psychological resilience to function effectively within such conceptually challenging environments. The navigation challenges of warp drive operations require developing entirely new frameworks for understanding position and motion within artificially manipulated spacetime. Conventional navigation relies on fixed reference points and consistent geometric relationships, but warp travel occurs within bubbles where the normal rules of distance and direction no longer apply. Navigation systems would need to track position relative to the artificially maintained spacetime geometry, while simultaneously monitoring the relationship between the warp bubble and normal space outside. The computational challenges of real-time navigation within exotic spacetime geometries would require processing capabilities that dwarf current supercomputing systems. Navigation computers would need to solve complex differential equations describing spacetime curvature, while simultaneously tracking the dynamic evolution of quantum field configurations that maintain the warp effect. These calculations would need to be performed continuously and updated faster than the characteristic timescales of warp field fluctuations. The communication systems required for warp drive operations face the fundamental challenge that electromagnetic radiation cannot easily escape from within warp bubbles during faster-than-light segments of travel. This creates periods of complete communications isolation that could last for days or weeks, depending on the journey, duration, and distance. Developing quantum entanglement-based communication systems that can maintain contact with the outside universe during warp travel represents a crucial technical challenge. The emergency procedures for warp drive malfunctions would need to address scenarios that have no analogue in conventional spacecraft operations. A catastrophic failure of exotic matter containment could release energies comparable to stellar explosions while simultaneously creating regions of wildly distorted spacetime that could tear apart anything in the vicinity. Emergency response protocols would need to account for the possibility that normal physics might not apply in the immediate aftermath of such failures. The training simulators required for warp drive crew preparation would need to accurately model the exotic physics of artificial spacetime manipulation while providing realistic training scenarios for emergency response. These simulators would essentially need to become quantum computers capable of modeling exotic spacetime geometries in real time, creating virtual environments where trainees can practice operating systems that manipulate the fundamental structure of reality itself. The maintenance and repair procedures for warp drive systems would require technicians capable of working with exotic matter containment systems and quantum field generators under potentially hazardous conditions. The diagnostic procedures alone would require understanding quantum field theory at a level currently reserved for theoretical physicists, combined with practical engineering skills for repairing systems that operate according to principles at the very edge of known physics. Consider the complexity of troubleshooting a malfunctioning quantum field generator while traveling through interstellar space within a bubble of artificially curved spacetime. The repair procedures would need to account for the possibility that tools and diagnostic equipment might behave differently within the exotic field environment, while simultaneously ensuring that any repairs maintain the delicate quantum coherence required for stable warp field operation. The quality control and testing procedures for warp drive components would need to verify performance under conditions that cannot be fully replicated in terrestrial laboratories. Testing exotic matter containment systems requires creating controlled regions of negative energy density, which might only be possible using smaller-scale versions of the same exotic physics principles that the full-scale systems employ. This creates circular dependencies in the development process that challenge conventional approaches to technology validation. The certification and safety standards for warp drive technology would need to address risks that extend far beyond the immediate vicinity of the spacecraft to potentially include effects on the fabric of spacetime itself. Regulatory frameworks would need to consider the possibility that poorly designed or operated warp drives could create lasting distortions in local spacetime geometry that might affect other spacecraft or even astronomical observations. The international cooperation required for establishing these safety standards would need to overcome not only technical challenges, but also fundamental disagreements about acceptable risk levels when dealing with technologies that manipulate the basic structure of reality. The decisions made regarding warp drive safety protocols could influence the development trajectory of the technology for generations, making these early regulatory choices crucial for the long-term future of interstellar travel. The insurance and liability frameworks for warp drive operations would need to address scenarios where accidents could potentially cause damage across multiple star systems or affect the properties of spacetime itself. Traditional insurance models, based on statistical analysis of historical accident data, would be inadequate for technologies that operate in regimes where no historical precedent exists. New actuarial methods would need to be developed based on theoretical physics calculations rather than empirical experience. The economic models for warp drive development and operation reveal complexities that challenge every existing framework for understanding technological investment and return. The research and development costs for achieving practical warp drive capability would likely exceed the gross domestic product of entire nations, requiring unprecedented levels of international cooperation and resource sharing. The economic benefits, however, could transform human civilization by opening access to resources and opportunities throughout the galaxy. The patent and intellectual property considerations surrounding warp drive technology raise questions about the ownership of discoveries that could benefit all humanity. Should the mathematical insights and engineering breakthroughs required for space-time manipulation be treated as proprietary information, or do they represent knowledge that rightfully belongs to our entire species? These decisions could influence whether warp drive technology develops as a tool for universal benefit or becomes a source of inequality and conflict. The workforce development requirements for supporting a warp drive industry would necessitate educational programs that combine advanced theoretical physics with practical engineering skills in ways that currently don't exist. Universities would need to develop curricula that prepare students to work with exotic matter systems, quantum field generators, and space-time manipulation technologies. The interdisciplinary nature of this field would require breaking down traditional academic boundaries between physics, engineering, computer science, and materials research. The supply chain considerations for warp drive manufacturing would need to encompass not only conventional materials and components, but also the exotic substances and quantum devices required for space-time manipulation. The production of exotic matter would likely require specialized facilities that operate under conditions found nowhere else in human industry, potentially including environments with artificially maintained quantum field configurations. The environmental impact assessments for warp drive operations would need to consider effects that extend far beyond traditional concerns about pollution or resource consumption. The manipulation of space-time geometry could potentially have consequences for astronomical observations, gravitational wave detection, or even the stability of local space-time structure. Environmental protection agencies would need to develop expertise in exotic physics to properly evaluate and regulate these unprecedented technological capabilities. The research ethics considerations surrounding warp drive development encompass questions about the responsible advancement of technologies that could fundamentally alter the trajectory of human civilization. The power to manipulate space-time itself represents capabilities that approach those traditionally attributed to deities in human religious traditions. Ensuring that such power is developed and employed responsibly would require ethical frameworks that go far beyond current guidelines for scientific research. As we drift deeper into these remarkable territories, where science fiction gradually transforms into engineering challenges, we begin to see how warp drive development would necessarily transform every aspect of human technological capability. The precision control systems, exotic materials, and quantum computational methods required for space-time manipulation would find applications throughout human industry, potentially revolutionizing manufacturing, medicine, communications, and energy production in ways we can barely imagine. The journey from our current understanding to practical warp drive implementation remains long and uncertain, filled with challenges that test the very limits of human knowledge and capability. Yet each advance in our understanding of exotic space-time physics brings us closer to recognizing that the universe might be far more accommodating to conscious intervention than our everyday experience suggests. The mathematical elegance underlying these possibilities continues to inspire wonder at the deep structures of reality itself. Tonight, as you rest in the familiar embrace of flat space-time, remember that you are already part of this cosmic adventure. Your consciousness, with its capacity to contemplate these exotic possibilities and find meaning in mathematical abstractions, represents one of the most extraordinary phenomena in the known universe. The thoughts flowing through your mind as you drift towards sleep might be early expressions of the same fundamental processes that will someday enable humanity to reshape reality itself through the elegant manipulation of space-time geometry. The boundaries between science fiction and scientific possibility continue to blur as our understanding deepens, revealing a universe that seems almost eager to accommodate the dreams and aspirations of conscious beings brave enough to reach beyond the apparent limitations of physical law. In the gentle rhythm of your breathing, in the quiet space between heartbeats, you touch something eternal that connects finite awareness to the infinite possibilities that quantum mechanics and general relativity reveal. Whether warp drives become reality in decades or centuries, the mathematical foundations we've explored tonight suggest that consciousness and cosmos are engaged in a dance of mutual discovery that has only just begun. The universe, it seems, has been waiting patiently for awareness to evolve to the point where it can begin to participate consciously in the ongoing creation of reality itself. And perhaps that participation begins not with exotic matter or curved space-time, but with the simple act of wondering, dreaming, and reaching toward possibilities that stretch beyond every horizon we can currently imagine. The story of warp drive physics has taken us on a remarkable journey through the deepest territories of theoretical possibility, where the elegant mathematics of general relativity reveals pathways toward dreams that once seemed forever beyond human reach. We've explored how space-time itself might be sculpted and shaped, how consciousness and cosmos might dance together in ways that transcend our current understanding, and how the universe appears to be far more accommodating to the aspirations of aware beings than our everyday experience might suggest. As we drift toward the end of our gentle voyage through these cosmic possibilities, it's worth reflecting on what this exploration reveals about the nature of human curiosity itself. The fact that conscious beings evolved within this universe can contemplate manipulating its fundamental structure suggests a kind of cosmic synchronicity that borders on the profound. We are not separate from the reality we study, but expressions of the universe's capacity to understand itself through the lens of awareness. The challenges we've encountered tonight, from exotic matter requirements to quantum field engineering, represent obstacles rather than impossibilities. The history of human achievement shows repeatedly that what seems impossible to one generation becomes routine engineering to the next. The precision manufacturing that enables our modern electronics would have seemed magical to engineers just decades ago. Perhaps future civilizations will manipulate space-time with the same casual expertise we now apply to manipulating matter and energy. The mathematical beauty underlying warp drive physics continues to inspire wonder at the deep structures that govern reality. These equations don't simply describe abstract possibilities, but reveal something fundamental about how consciousness and cosmos might be intimately connected. The universe appears to be constructed in such a way that awareness naturally evolves toward the capability to reshape the very foundations of existence itself. Whether warp drives emerge in our lifetimes or remain dreams for future generations, the journey of exploration itself transforms us. In contemplating these exotic possibilities, we expand not just our knowledge, but our capacity for wonder, our willingness to embrace mystery, our ability to find meaning in reaching toward horizons that stretch beyond all direct experience. Tonight, as you settle into the familiar embrace of normal space-time, remember that you carry within you the same cosmic mystery that gives birth to stars and galaxies, to consciousness and dreams. The gentle rhythm of your breathing connects you to the quantum heartbeat of reality itself, while your thoughts reach across impossible distances to touch possibilities that may someday transform humanity's relationship with the infinite cosmos. Sweet dreams, fellow traveller. May your rest be filled with visions of curved space-time and cosmic highways, where consciousness rides waves of possibility toward destinations among the distant stars, carried by the elegant mathematics that weave wonder into the very fabric of existence itself.